Alright, we're going to be going over problem number 9, chapter 13.9. You're given the volume of a rectangular room at 668.25 cubic feet. The cost of wall paint is 6 cents per square foot, and the cost of ceiling paint is 11 cents per square foot. You define the room dimensions to minimize the cost of the paint and determine the cost. So we start with drawing a little diagram, assigning our x, y, z coordinates. And starting with the volume equation, we get x times y times z equals the volume of 668.25. Solving for z now, you get 668.25 divided by x times y. Our cost function of x, y, and z equals 2 times 0.06, z times y, this surface and its opposite surface, plus 2 times 0.06, x times z, this and its opposite surface, and plus 0.11, x times y, the ceiling. Substituting in z, you get 0.12y times quantity 668.25 divided by xy plus 0.12x times quantity 668.25 divided by xy plus 0.11xy. Simplifying, 0.12 times 668.25 over x plus 0.12 668.25 over y plus 0.11 x times y. Now to find our critical point, we start with taking our partial derivatives. C sub x equals 0.12 times negative 668.25 over x squared plus 0.11y, and C sub y equals 0.12 times negative 668.25 over y squared plus 0.11x. Set both equal to 0, solve for x and y. So over here you get negative 80.19 over x squared, multiplying in 0.12, plus 0.11y equals 0. Add this over to the other side. 0.11y equals 80.19 over x squared. Dividing by 0.11, you get y equals 729 over x squared. Substitute this in the c sub y. Negative 80.19 divided by the quantity of 729 divided by x squared, quantity squared, plus 0.11x. Again, moving this over, 80.19 x to the fourth over 729 squared equals 0.11x. Alright, you can multiply over 729 squared over to the other side. You get 80.19 x to the fourth equals 58,458.51x. Dividing by x and 80.19, you get x to the third equals 729. Or x equals 9, take the cube root. And now that you have both x and y, you can substitute into your z function, solve for z. 668.25 divided by 9 times 9, or 81, equals 8.25. These will be the dimensions of the room to minimize the cost. And now to prove that this is the minimum, take our second partial, c sub xx equals 0.12 times 1,336.5 over x to the third. Alright, substitute in your c sub xx at your 0.9, you're going to get 1.83 as its value. And since that is greater than 0, this function is concave up and will have a relative minimum at 9, solving for your total cost. You can use your original c function of x, y, and z, and you're going to get a value of $26.73. Now putting this into words, this room will have a minimum paint cost of $26.73 if the area of the floor is 9 feet by 9 feet with a height of 8.25 feet. Just reviewing what we did, started off with our two functions, substituting one into the other, substituting the volume function, solved for z, into the cost function, taking our partial derivatives, setting them equal to 0, solving for x and y, in this case 9 and 9, taking those two values, substituting in for our c equation, which was from the volume function we derived earlier, checking to make sure that this is a minimum with c sub xx, determining the total cost, substituting back into the cost function of our known x, y, and z values, and putting this into words. Thanks for watching.